Hello, welcome to my channel Nightlight Science Stories. Today, we are embarking on a truly magical journey together to explore the depths of the universe and the edge of time. It is wonderful to have you here. In this video, we will travel beyond the familiar stars, witnessing the silent dance of galaxies and the mysterious forces that shape our reality. So sit back, relax, and let your imagination soar into the infinite cosmos with me. As we leave the comfort of our home planet, the noise of everyday life fades into a profound silence. We are not just observers. We are travelers in time. Every star we see is a ghost from the past, their light taking millions of years to reach our eyes. The universe is a vast ocean of mystery, waiting to be explored. From the glittering birth of nebulas to the terrifying grip of black holes, every corner of this dark expanse holds a secret story. We begin our deep dive at the most enigmatic object in existence, the supermassive black hole. Standing at the event horizon, we see the laws of physics crumbling into dust. Gravity here is so intense that it bends light itself, creating a halo of warped reality. The darkness is not empty. It is heavy with the weight of consumed stars. It whispers ancient secrets to those brave enough to look closer, marking the boundary where our knowledge ends. Drifting nearer to the point of no return, time begins to lose its meaning. A single second here stretches into centuries on Earth, bridging the past and the infinite future. The swirling colors of the accretion disk paint a masterpiece of destruction, glowing with a mystical energy that outshines entire galaxies. This is the edge of time, where the universe keeps its deepest mysteries locked away in a prison of eternal gravity and silence. Leaving the darkness behind, we enter a realm of creation, a stellar nursery. These towering pillars of gas and cosmic dust are the wombs of the universe, where new stars are born in a chaotic dance. The vibrant hues of pink and teal are not just beautiful. They are the visual signature of hydrogen and helium fusing under immense pressure. It is a silent, majestic cathedral where the building blocks of life are forged in the heart of the void. Deep within these glowing clouds, gravity pulls dust together until it ignites, sparking the first light of a baby sun. This process takes millions of years, a blink of an eye in cosmic time. We are witnessing our own origins, for every atom in our bodies was once cooked in a furnace like this. The universe is a cycle of death and rebirth. And here, amidst the stardust, we see the beautiful violence of creation in its purest form. We now approach the dense remnant of a dead star, the neutron star. Though only the size of a city, it holds more mass than our sun, packed so tightly that a teaspoon of its matter would weigh billions of tons. The gravity here is crushing, smoothing the surface into an almost perfect sphere. The blue lines of magnetic energy crackle across the horizon, singing a deadly song of radiation. It is a place of extremes, where matter is squeezed into a strange metallic soup. This celestial object spins at a dizzying speed, acting as a cosmic lighthouse that pulses with precise rhythm. These pulses are the heartbeats of the galaxy, keeping time in the vast emptiness. The magnetic fields are so strong they would rip the atoms from your body before you even touch the surface. Yet, in this hostile environment, we find a strange kind of order. It reminds us that the universe is governed by forces of terrifying power. On a scale that dwarfs our imagination, we witness the collision of two spiral galaxies. This is a cosmic ballet that unfolds over billions of years. Stars are flung out into the void like sparks from a fire, creating long tails of light that stretch across the darkness. It looks like destruction, but it is actually a merger, a marriage of millions of star systems. The gravity of each galaxy distorts the other, twisting their shapes into a new form. Despite the chaos, actual collisions between stars are rare because the space between them is so vast. Instead, they pass by each other like ghosts in the night, dancing to a new gravitational tune. This event triggers a burst of star formation, lighting up the darkness with fresh energy. It is a reminder that in the cosmos nothing is static. Everything is in motion, evolving, and transforming in a spectacular display of light and gravity. Now we must look at what cannot be seen. Between the shining galaxies lies the cosmic web, a vast skeleton made of dark matter. It is invisible to our eyes, yet it holds the universe together like a giant spider web. We can only detect it by the way its gravity pulls on visible light. It is the silent architect of the cosmos, dictating where galaxies grow and where the voids remain empty. Without it, the universe would fly apart. This mysterious substance makes up most of the matter in the universe, yet we still do not know what it is. It is a ghost in the machine, passing through us every second without a trace. Visualizing it as a glowing purple grid helps us understand its crucial role. It connects the desperate islands of light across the abyss, proving that everything in this vast expanse is intimately connected by invisible threads of gravity and ancient energy. Let us descend onto the surface of a distant exoplanet, a world orbiting two suns. The sky here is a canvas of shifting colors, with double shadows stretching across a landscape of crystalline flora. It is a scene straight out of science fiction, yet the universe is filled with such wonders. The biology here might be based on silicon instead of carbon, creating life forms that are completely alien to our understanding of nature. As night falls, the sky comes alive with an aurora borealis that spans the entire horizon. The magnetic field of this world protects it from the stellar winds of its binary stars. Standing here, we realize that Earth is just one possibility among trillions. Somewhere out there, perhaps another being is looking up at their own strange sky, wondering if they are alone. The diversity of worlds is as infinite as the stars themselves. We are now witnessing the violent death of a massive star, a supernova. When a star runs out of fuel, it collapses under its own weight and then explodes with the brilliance of a billion suns. This shock wave of energy tears through the surrounding space, destroying everything in its path. It is a moment of pure cosmic fury, a spectacular finale that marks the end of an era for a solar system. But in this destruction lies the seed of life. The explosion scatters heavy elements like iron, gold, and carbon into the cosmos. These are the ingredients that will one day form new planets and perhaps new life. The iron in your blood and the calcium in your bones were forged in an explosion just like this one. We are literally made of stardust, connected to the death of ancient stars in the most intimate way possible. We travel further out, entering the Great Void. This is a region of space so empty that you could travel for millions of years and encounter nothing but a few stray atoms. It is a desert of the cosmos, a place of profound isolation and cold. The galaxies here are distant specks of light, islands of warmth in a limitless ocean of nothingness. The silence here is absolute, a heavy blanket that covers the deep dark. This emptiness teaches us about the scale of reality. We are accustomed to clutter and noise, but most of the universe is simply empty space. It is a humbling perspective, reminding us of how fragile and rare our existence is. Yet, even in this void, quantum fluctuations occur, popping in and out of existence. The nothingness is alive with potential energy, proving that true emptiness is perhaps just an illusion of our limited senses. Suddenly, a blinding light pierces the darkness. We have found a quasar, the brightest object in the universe. Powered by a supermassive black hole feeding on gas, it shoots jets of energy across the cosmos at nearly the speed of light. It shines so brightly that it can be seen from the other side of the universe, a beacon of raw power that outshines the galaxy that hosts it. Is a monster awake in the dark? The energy released by a quasar in a single moment is more than our sun will produce in its entire lifetime. These are the ancient engines of the early universe, shaping the growth of galaxies when the cosmos was young. Looking at a quasar is like looking back in time to a more violent and energetic era. It stands as a testament to the ferocious forces that govern the deep sky, burning with an unquenchable fire. We travel back to the very beginning, tuning our senses to the oldest light in existence, the cosmic microwave background. This faint glow fills every corner of the sky, a fossil from the moment the universe cooled enough for light to travel freely. It is the echo of the Big Bang, a snapshot of the cosmos when it was just a baby, only 380,000 years old. Before this moment, everything was in opaque fog. Seeing this map is like reading the fingerprint of creation itself. The slightly different colors in this map represent tiny fluctuations in temperature. These minute differences are the seeds of everything we see today. Without these tiny imperfections, gravity would have had nothing to pull together, and galaxies, stars, and planets would never have formed. We are here because the early universe was not perfect. This ancient light whispers the story of how a chaotic explosion transformed into the structured beauty we inhabit today. Not all planets have the warmth of a sun. Meet the rogue planets, the orphans of the galaxy. These worlds were kicked out of their solar systems by gravitational chaos and now drift alone in the eternal night. Without a star to light their way, they travel in frozen silence through the interstellar void. They are invisible to our telescopes, detectable only by the way they briefly bend the light of distant stars behind them. It is a lonely and haunting existence. Yet, even in this darkness, life might find a way. Beneath thick layers of ice, geothermal vents powered by a molten core could keep oceans liquid for billions of years. These wandering worlds might be carrying life through the galaxy like cosmic arcs, seeding new systems if they are ever captured by a star. It challenges our definition of a habitable zone, proving that a planet does not need a sun to be alive, only an internal fire to keep the cold at bay. We return to the Eagle Nebula to witness the iconic pillars of creation. These elephant trunks of interstellar gas and dust are light years tall, sculpted by the fierce winds of nearby massive stars. They look solid like stone monuments, but they are actually tenuous clouds constantly shifting and eroding. The ultraviolet light from young stars is slowly boiling them away, creating a halo of glowing gas that outlines their majestic and towering shapes against the void. Is a race against time. Inside these pillars, new stars are collapsing and igniting, trying to emerge before their nursery is destroyed. We see small protrusions called EGGs, or evaporating gaseous globules, where embryonic stars are hiding. It is a violent and beautiful struggle between creation and destruction. In a few million years, these pillars will be gone, blown away by the very stars they helped create, leaving only a cluster of bright young suns. Imagine a star with a magnetic field a quadrillion times stronger than Earth's. This is a magnetar, a rare and terrifying type of neutron star. If a magnetar entered our solar system, it would wipe the credit cards in your pocket from the distance of the moon. Its magnetic grip is so powerful that it distorts the shape of atoms, stretching them into thin needles. The environment here is hostile beyond measure, dominated by invisible forces of immense power. Occasionally, the crust of a magnetar cracks under the strain, causing a starquake. This releases a blast of high-energy gamma rays that can travel across the galaxy. One such flare, from 50,000 light-years away, was strong enough to affect Earth's upper atmosphere. These outbursts are the most powerful magnetic events in the universe, a reminder that out in the deep black, there are monsters capable of touching us across the vast distances of space. We venture into the realm of the possible, a Dyson sphere. As civilizations advance, they crave more energy. A Type 2 civilization might build a massive shell around their star to capture all of its solar output. Looking at this megastructure, we see a geometric web encompassing the sun, harvesting its fire to power unimaginable technologies. It blocks the visible light, but glows brightly in infrared, a heat signature of intelligent life hiding in the dark. This concept brings us to the Fermi paradox. If the universe is so old and vast, Where is everyone? Are we the first to wake up, or are the ruins of ancient empires floating in the void, waiting to be found? Perhaps advanced beings live in these digital utopias powered by stars, uninterested in space travel. The silence of the universe is either a sign of our rare solitude or a warning that we have not yet learned how to listen to the cosmic choir. Fast forward billions of years to the fate of our own sun. It will shed its outer layers and shrink down to become a white dwarf. This Earth-sized diamond is the glowing core of a dead star, slowly cooling over trillions of years. It no longer performs fusion but shines with stored heat, a fading ember in a cosmic night. Around it, the shattered remains of its planets form a debris disk, a graveyard of a solar system that once teemed with energy. Eventually, even this light will go out. The white dwarf will cool until it becomes a black dwarf, a cold, dark crystal floating unseen in space. This process takes longer than the current age of the universe, so no black dwarfs exist yet. It is a lonely future, a testament to entropy. But for now, these white dwarfs stand as beautiful monuments to the stars they once were, illuminating the planetary nebulae that bloom like flowers around them. At the very edge of the solar system lies the Oort cloud, a spherical shell of icy debris. This is the home of the long-period comets, frozen wanderers that occasionally dive toward the sun. It is a vast cold frontier, extending nearly a light year out. Here, the sun is just another bright star in the sky, its gravity barely holding onto these icy rocks. It acts as a protective bubble, marking the true boundary between our home and interstellar space. Every few million years, a passing star might nudge this delicate balance, sending a shower of comets raining down into the inner solar system. These visitors bring water and organic compounds to planets, but they can also bring destruction. The Oort cloud is a reservoir of ancient history, preserving the pristine material from the solar system's birth. It is a frozen time capsule, guarding the secrets of how our world was first assembled. Imagine a spacecraft accelerating towards the speed of light. As we get faster, the stars in front of us shift to blue and the universe appears to tunnel. This is the realm of relativity, where space and time become fluid. The faster we move through space, the slower we move through time. If we returned to Earth after a journey at this speed, everyone we knew would be long gone. We would have traveled into the future, leaving the past behind. This is not science fiction. It is the fabric of our reality. Clocks on GPS satellites tick faster than those on the ground because of this effect. At the speed of light, time stops completely. A photon experiences no time between its birth in a star and its arrival at your eye. For light, the journey is instantaneous. It is a mind-bending concept that reveals that time is not a fixed river, but a landscape that can be traversed at different speeds. Millions of galaxies, including our own Milky Way, are being pulled towards a mysterious anomaly known as the Great Attractor. It lies hidden behind the dust of our own galaxy's plane, the zone of avoidance. We cannot see it clearly, but we can feel its immense gravity. It is a gravitational giant, pulling everything in our supercluster towards a central point. Is it a concentration of dark matter or something far more exotic and massive? This flow of galaxies reveals our true address in the cosmos. We live in the Laniakea supercluster, meaning immeasurable heaven. Like water flowing down a mountain, galaxies flow along cosmic filaments towards this attractor. It is a reminder that we are part of a much larger structure, a web of matter stretching across billions of light years. We are drifting through the universe in a great river of stars, headed towards an unknown destination. Einstein's equations allow for a shortcut through space-time, a wormhole. Visualize a tunnel connecting two distant points in the universe, folding the fabric of space like a piece of paper. Stepping through this glowing portal could take us to a galaxy billions of light years away in a single step. It is the holy grail of interstellar travel. Though we have never found one, the math suggests they could exist, hidden in the quantum foam. A wormhole is not just a bridge through space. It could also be a bridge through time. Traversing it might allow us to witness the building of the pyramids or the end of the Earth. But this brings paradoxes. Can the past be changed? Or is time a closed loop? These portals remain in the realm of theory, tantalizing us with the possibility that the vast distances of the universe are not insurmountable walls, but puzzles waiting to be solved. We drift now to the coldest place in the known universe, the Boomerang Nebula. While the background of space is freezing, this ghostly cloud is even colder, hovering just 1 degree above absolute zero. At this temperature, the fundamental movement of atoms almost completely ceases. It is a place of deep freeze, shaped by winds blowing at supersonic speeds. The ghostly blue shape resembles a bow tie, a frozen monument in the void where thermodynamics hits its limit. Why is it so cold? As the central star sheds its outer layers, the gas expands so rapidly that it cools down drastically, acting like a cosmic refrigerator. Standing here, you would be in the quietest, stillest place in existence. Even the cosmic microwave background radiation, which warms the rest of the universe, cannot penetrate this icy veil. It is a chilling reminder that the universe contains extremes that challenge our understanding of physics and chemistry. Now we witness the most luminous electromagnetic event in the universe, a gamma-ray burst. These narrow beams of intense radiation are usually released during the collapse of a massive star into a black hole. In just a few seconds, a single burst releases more energy than our sun will emit in its entire 10 billion-year lifetime. It is a sniper shot from the deep cosmos. If one were to strike Earth directly, it would strip away our ozone layer instantly. These cosmic death rays are likely responsible for mass extinctions in the past. They travel across the universe like silent assassins, invisible until they strike. Fortunately, most occur in distant galaxies, far from our home. However, the sheer power contained in these beams is terrifying. They serve as a reminder that life is fragile and exists at the mercy of high-energy physics. We are lucky to live in a quiet, boring corner of the Milky Way galaxy. Looking at our own galaxy, the Milky Way, we see something invisible to the naked eye, the Fermi bubbles. These are 2 colossal lobes of gamma-ray emitting gas that extend 25,000 light-years above and below the galactic plane. They are the remnants of a massive energetic event from the past, perhaps an outburst from the supermassive black hole at our galaxy's center. They stand like giant, invisible balloons, tethered to the heart of our galactic home. These bubbles contain gas that is millions of degrees hot, moving at millions of miles per hour. They tell us that our galaxy was not always the peaceful spiral we see today. Millions of years ago, the core was active and violent, feasting on matter and belching out high-energy particles. We are living in the aftermath of a galactic feast, and these glowing lobes are the fossilized evidence of a time when the Milky Way was a much more dangerous place. We have spoken of gravity pulling things together, but there is a darker force pushing them apart, dark energy. This mysterious pressure makes up roughly 68% of the universe and is causing the expansion of the cosmos to accelerate. Unlike gravity, which weakens with distance, dark energy seems to be a property of space itself. The more space there is, the more dark energy exists, pushing galaxies away from each other faster and faster into the dark. This force will determine the ultimate fate of the universe. If it continues to grow, it will eventually tear everything apart in a big rip, shredding galaxies, stars, and eventually atoms themselves. It is the invisible hand stretching the canvas of reality. We cannot see it, taste it, or touch it, yet it dominates the cosmos. It is the greatest unsolved problem in physics, a phantom energy that dictates the destiny of every star in the sky. What if our universe is not the only one? Enter the theory of the multiverse. Imagine an infinite ocean where our entire cosmos is just a single bubble among countless others. In some bubbles, the laws of physics might be completely different. Gravity might be repulsive, or light might travel slowly. In another bubble, perhaps dinosaurs never went extinct, or you made a different choice this morning. The possibilities are truly infinite and mind-bending. This idea arises from the theory of eternal inflation, suggesting that the Big Bang was not a unique event, but a continuous process. While we can likely never contact these other universes, the math suggests they are there. It makes our existence feel incredibly small, yet infinitely significant. We are just one experiment in a grand, never-ending laboratory of realities, floating in a sea of eternal creation where every possibility eventually happens. Now we travel to the very end of time, the heat death. Billions of years from now, the last star will burn out. The universe will become a cold, dark graveyard scattered with black holes and dead remnants. As the expansion continues, even particles will drift so far apart that they never interact. This is the state of maximum entropy, where no energy can be exchanged, and therefore, no life or thought can exist. It is the ultimate silent night. But do not despair. This process will take trillions upon trillions of years. Even the black holes will eventually evaporate through Hawking radiation, leaving nothing but a bath of photons. It is a poetic end. The universe started in a burst of light and will end in a whisper of light. Until then, we have an eternity to explore, to create, and to understand. The darkness is not a threat, but a canvas for the brief, brilliant spark of life to shine. Deep inside neutron stars, matter is squeezed so hard it might turn into something exotic called strange matter. This is the most stable form of matter in the universe. Theory suggests that if a piece of strange matter, a strangelet, were to escape and touch normal matter, it would instantly convert it into more strange matter. It would act like a cosmic infection, transforming a planet or a star into a hot, strange lump of cork soup. While this sounds like science fiction horror, it is a legitimate possibility in quantum physics. Fortunately, strangelets are likely confined to the cores of dead stars. However, it shows us that the stability of our world is not guaranteed. The universe is built on a delicate balance of forces. There are states of matter so perfect and so powerful that they could overwrite reality as we know it, simply by making contact with our imperfect atoms. Let us lighten the mood with a visit to 55 Cancri, the diamond planet. This super-Earth is twice the size of our world and orbits extremely close to its star. Because it is rich in carbon and under immense pressure, scientists believe its interior is composed largely of diamond. Imagine mountains and continents made of pure crystal, sparkling under a blazing sun. It is a jewel hanging in the darkness, with a value that exceeds all the money on Earth. Of course, you couldn't visit. The surface temperature is over 2,000 degrees Celsius, and it likely rains molten lava. Yet, the existence of such a world reminds us of the chemical diversity of the galaxy. Planets are not just rocks and gas. They can be made of gemstones, water, or iron. The universe is a treasure chest, filled with worlds that defy our expectations and surpass our wildest dreams of wealth and beauty. We look now to our own future. The Andromeda Galaxy is rushing towards the Milky Way at 110 kilometers per second. In about 4 billion years, our skylines will change forever as these two giants collide to form Milkometa. It won't be a crash, but a ghostly merger. The night sky will be filled with the bright cores of two galaxies, a view of breathtaking beauty. New stars will be born from the compressed gas, lighting up the night. Curiously, because space is so empty, it is unlikely that any two stars will actually hit each other. Our solar system will simply be flung into a new orbit. Any life existing on Earth then would see a spectacular light show lasting for millions of years. It is a reminder that the map of the heavens is not fixed. We are on a collision course with destiny. participating in a galactic dance that began shortly after the Big Bang. To understand our place in all this, imagine the entire history of the universe compressed into a single calendar year. The Big Bang happens on January 1st at midnight. The Milky Way forms in May. Our solar system doesn't appear until September. Complex life on Earth only emerges in late December. In this cosmic calendar, all of human history, every king, every war, every invention happens in the very last seconds of December 31st. This perspective is called the cosmic calendar. It shows us how young we effectively are. We have only just opened our eyes to the universe. For most of history, the cosmos existed without us to observe it. We are the universe's way of knowing itself, a fleeting moment of consciousness in a vast ocean of time. It is a humbling thought, but also an empowering one. We are the custodians of the only known spark of meaning in the dark. We return to the silence of the sky and the great filter theory. It suggests there is a barrier to the evolution of intelligent life that is extremely difficult to cross. Perhaps life arises often, but civilizations tend to destroy themselves with their own technology before reaching the stars. This scary thought explains why, in a universe filled with planets, we seem to be alone. The silence might be the sound of a cosmic graveyard where others failed to survive. This filter could be behind us, meaning we are lucky survivors, unique and rare. Or, terrifyingly, the filter could be ahead of us. Are we walking blindly into a trap that has wiped out everyone else? Looking for aliens is not just curiosity. It is a search for our own future. If we find ruins, it is a warning. If we find nothing, the responsibility to keep the flame of consciousness alive rests solely on us. We must become the species that passes the test. Look closely at the fabric of reality. Some physicists suggest we might be living in a simulation. As our own video games become indistinguishable from reality, it is possible that a highly advanced civilization could simulate an entire universe. If this is true, the laws of physics are just computer code, and the speed of light is the processing limit of the system. We might be artificial intelligence in a grand experiment, unaware of the true nature of existence. Quantum mechanics reveals that reality is pixelated at the smallest scale, known as the Planck length. This grid-like structure looks suspiciously like computer data. Strange glitches where particles exist in two places at once might be optimization tricks of the simulator. Does it matter if we are real or code? Perhaps not. The beauty of the nebula and the love we feel are real to us. But it forces us to question, who is the programmer holding the controller? For every particle of matter, there's an opposite twin, antimatter. It has the same mass but opposite charge. When matter and antimatter meet, they annihilate each other instantly in a burst of pure energy. The Big Bang should have created equal amounts of both, meaning they should have canceled each other out, leaving nothing but light. Yet, here we are. Something tipped the balance in favor of matter, allowing the universe to exist. Where did the antimatter go? Scientists believe there might be vast clouds of antimatter hiding in the deep cosmos, or even entire anti-galaxies made of anti-stars. If you were to visit such a world and shake hands with your anti-self, you would both explode with the force of 1,000 nuclear bombs. This missing half of reality is one of the biggest mysteries in physics. We are the leftovers of a great cosmic battle between existence and nothingness, and luckily, matter won the war. Prepare yourself for the Boat's void, often called the Great Nothing. It is a massive sphere of empty space, 330 million light-years across. While a region this size should contain thousands of galaxies, this void contains only about 60. If the Milky Way were in the center of this void, we would not have discovered other galaxies until the 1960s. We would have thought we were truly alone in an endless dark box, isolated from the rest of the cosmos. How did such a massive hole form in the universe? It is too big to be explained by standard gravity models. Some theorize it is the result of merging voids, while others whisper of darker possibilities. Perhaps an ultra-advanced civilization consumed all the stars in that region, harvesting them for energy and leaving only darkness behind. It stands as a chilling reminder that the universe is patchy, with vast deserts of silence separating the islands of light. Not all black holes stay put in the center of galaxies. Some are rogue black holes, wandering predators that were kicked out of their homes by gravitational slingshots. They drift silently through interstellar space, invisible and deadly. We cannot see them coming. We can only detect them if they pass in front of a background star, warping its light for a brief moment. There could be one passing through our cosmic neighborhood right now without us knowing. While the chances of one hitting Earth are astronomically low, the idea is terrifying. It would not be a collision. It would be a silent erasure. The solar system would simply be disrupted or swallowed. These wandering monsters are the ghosts of the galaxy, prowling the dark corners between the stars. They remind us that the galaxy is dynamic and dangerous, not a static clockwork mechanism, but a chaotic sea where monsters swim in the deep. Gravity is not just a force, it is also a lens. Massive objects like galaxy clusters warp the fabric of space so much that they bend light passing nearby. This creates a natural telescope called gravitational lensing. It allows us to see objects that are hidden behind other galaxies, magnifying them and stretching them into arcs or rings known as Einstein rings. We are literally seeing around corners in the universe, using gravity to cheat geometry. This cosmic magnifying glass allows us to spot the oldest and most distant galaxies that formed just after the Big Bang. Without this natural assistance, they would be too faint for our telescopes to detect. It is a beautiful collaboration between nature and technology. The mass of the universe helps us uncover its own history, bending the light of the past to bring it into our present view. It turns the entire cosmos into a giant optical instrument. Did life begin on Earth, or did it arrive from the stars? The theory of panspermia suggests that life exists throughout the universe and is distributed by comets and meteoroids. We have found organic building blocks on asteroids and icy moons. It is possible that the first seeds of life hitched a ride on a rock ejected from Mars or another system, crashing into our primordial oceans. We might all be aliens, descendants of microbial travelers. Some microscopic animals, like tardigrades, can survive the vacuum of space. This resilience suggests that life is not fragile but stubborn. If this theory is true, the galaxy could be teeming with biological cousins waiting to be found. The universe acts like a gardener, spreading the spores of life across vast distances. We are not an isolated miracle, but part of a cosmic ecosystem that connects planetary systems through the exchange of biological material. We think of the Big Bang as the start, but what if it was just a restart? The Big Bounce theory proposes that the universe goes to infinite cycles of expansion and contraction. Like a cosmic lung, it breathes out into a Big Bang and breathes in into a big crunch, only to explode again. In this view, time has no beginning and no end. Our universe is just the current iteration in an eternal chain of universes. If this is true, the laws of physics might differ slightly each time. Perhaps there was a version of you in the previous cycle, living a slightly different life. It gives the cosmos a rhythm, a heartbeat that spans eons. It removes the problem of what came before the beginning, because there was no beginning. The universe is an eternal phoenix, constantly rising from its own ashes, playing out the drama of existence over and over again, forever. Deep down, the universe gets weird. Quantum entanglement is a phenomenon where two particles become linked, sharing the same existence. If you change the state of one, the other changes instantly, even if it is on the other side of the universe. Einstein called this spooky action at a distance because it seems to break the speed of light limit. It suggests that at a fundamental level, distance is an illusion and everything is connected. This connection defies our common sense. It implies that space is not an empty void that separates things, but a medium that connects them. Some theories suggest that the fabric of spacetime itself is stitched together by these quantum threads. It hints at a deeper layer of reality where separation does not exist. We are all made of particles that have interacted since the Big Bang, meaning we are all entangled with the cosmos in a complex invisible web. We end this segment staring into the Eye of God, the Helix Nebula. It looks like a giant cosmic eye watching us from the dark. In reality, it is a star similar to our Sun that has reached the end of its life, puffing off its outer layers into space. The pupil of the eye is the dying white dwarf star in the center. It is a hauntingly beautiful portrait of death, showing us exactly what our own solar system will look like in the future. The gas expelled here will eventually drift away to form new stars and planets. The death of one star gives life to the next. The beauty of the nebula captures the bittersweet nature of the universe. Destruction creates beauty. It watches over us not with judgment, but with the silent wisdom of eons. It is a mirror reflecting our own destiny, a reminder that we are fleeting moments in a process that is both destructive and endlessly creative. We venture into a new phase of matter, time crystals. Ordinary crystals, like diamonds, have atoms arranged in a repeating pattern in space, but time crystals are different. Their atoms repeat a pattern in time. This means they oscillate and change forever without burning any energy, technically breaking the laws of time symmetry. It sounds like a perpetual motion machine, impossible in classical physics, yet here they are, ticking eternally in the quantum realm. Created in labs using quantum computers, these strange structures prove that matter can exist in states we never dreamed of. They don't sit still. They dance to a rhythm that never stops, even when at their lowest energy state. This discovery could revolutionize technology, leading to memory storage that survives the end of the universe. It is a glimpse into a physics where time itself is a material component, woven into the very structure of reality. Imagine a wall made not of bricks but of galaxies. The Boss Great Wall is a superstructure consisting of over 800 galaxies and massive amounts of gas, stretching approximately 1 billion light-years across. It is one of the largest structures ever found in the universe. To fly from one end to the other at the speed of light would take 1 billion years. It is a titan that defies our understanding of how matter clumped together after the Big Bang. The existence of such a massive object challenges the cosmological principle, which states that the universe should look relatively smooth and uniform on large scales. This wall is a giant wrinkle in that theory. It suggests that gravity acted in ways we don't fully understand in the early universe, pulling matter into colossal filaments. We are like ants looking at a mountain, realizing that the architecture of the cosmos is far grander than we thought. Usually, when a white dwarf star explodes in a supernova, it is completely destroyed. But sometimes, the star survives the blast. These are called Type IX supernovas or zombie stars. They are blown apart, losing half their mass, but the core remains, hurtling through the galaxy like an undead traveler. These scarred survivors are battered and strange, burning with a weak and erratic light, refusing to die even after a cataclysmic event. Finding a zombie star is like finding a shipwreck that is still sailing. They challenge our models of stellar death. What happens to a star that has technically died but keeps shining? Its internal chemistry is altered, mixed by the explosion. It drifts through the void, a testament to resilience. In a universe of violent ends, these stars are the stubborn exceptions, proving that sometimes you can walk away from your own destruction. In the heat map of the early universe, the cosmic microwave background, there is an anomaly, the cold spot. It is a massive region that is significantly colder than its surroundings. Standard physics cannot easily explain why this large area lacks heat. Some scientists propose a mind-blowing theory. This spot is a bruise. It might be the point where our universe collided with another bubble universe eons ago, leaving a permanent scar on the sky. If this is true, it is the first physical evidence of the multiverse. Imagine two bubbles floating in a cosmic foam, bumping into each other. The energy transfer from that collision cooled this region of space. Looking at the cold spot might be looking at the imprint of a parallel reality, a window into a cosmos beyond our own. It transforms the sky from a simple map into a history book of interdimensional interactions on a scale we can barely conceive. Galaxies are not peaceful islands, they are predators. Galactic cannibalism is the process where a large galaxy, like our Milky Way, tears apart and consumes a smaller dwarf galaxy. We can see streams of stars wrapping around our galaxy, the crumbs of a past meal. It is a slow, gravitational digestion that takes billions of years. The smaller galaxy is stretched and distorted until it loses its identity, merging completely with the larger host. This isn't just destruction, it is how galaxies grow. The Milky Way built its majestic spiral arms by eating its neighbors. Right now we are consuming the Sagittarius dwarf galaxy. It reminds us that the universe is a place of survival of the fittest, even on the grandest scales. We are living inside a cosmic conqueror, a galaxy made of the stolen stars of a dozen fallen empires, continuing its feast through the eons of time. Why haven't we heard from aliens? The dark forest theory offers a chilling answer. It suggests the universe is like a dark forest at night, prowled by armed hunters. If a hunter sees another life form, he shoots to kill to ensure his own survival. In this scenario, every civilization stays silent to avoid being detected. Broadcasting messages into space, as we have done, is like a child crying in a forest full of wolves. It is a beacon for death. This theory turns the Fermi paradox into a horror story. The silence of the universe isn't empty, it is terrified. Advanced civilizations know that contact leads to conflict, so they hide or destroy anyone who reveals their location. If this is true, our search for extraterrestrial intelligence is a suicidal game. We are shouting hello into the dark, unaware that the reason no one answers is that the graveyards are full of those who spoke first. The most terrifying end of the world is vacuum decay. It is based on the idea that the Higgs field, which gives mass to particles, might not be in its most stable state. It could be in a false vacuum. If a quantum fluctuation occurs, a bubble of true vacuum could form. This bubble would expand at the speed of light, rewriting the laws of physics inside it. It would delete everything: stars, galaxies, atoms, replacing them with a different reality. Because it travels at light speed, we would never see it coming. One moment we exist, the next we are gone. The universe as we know it would simply cease to be. It could start anywhere, at any time. While unlikely, the math allows for it. It is the ultimate cosmic reset button, a reminder that the stability of our existence hangs on a delicate quantum thread. We walk on thin ice over a deep ocean of chaos, trusting the ice won't break. Closer to home, a mystery lurks at the edge of our solar system, Planet 9. Astronomers have noticed that icy objects in the Kuiper belt are clustering in strange orbits, as if pulled by a massive unseen gravity. The math suggests a super-Earth, 10 times the mass of our world, is hiding in the dark, far beyond Pluto. It takes thousands of years to orbit the Sun, a frozen giant that has evaded our telescopes for centuries. If it exists, it changes our understanding of the solar system. It would be a true planet, not a dwarf, ruling the outer dark. Why haven't we seen it? Because it is so far away that it reflects almost no sunlight. We are hunting for a ghost using gravity as our guide. Finding Planet 9 would be the discovery of the century, proving that even in our own backyard, there are massive secrets waiting to be illuminated. We know black holes swallow everything, but Einstein's equations also allow for their opposite: white holes. A white hole is a region of space-time that you cannot enter, only leave. Instead of pulling matter in, it spews light and information out. Nothing can remain inside a white hole. While we have never seen one, they remain a valid mathematical possibility. Some theorize they are the other side of a black hole, a cosmic exit door. This leads to a wild idea. Maybe the Big Bang itself was a massive white hole, exploding the universe into existence. Or perhaps when a black hole dies, it bounces back as a white hole, releasing everything it ever ate. They represent the breathing out of the cosmos. If they exist, they are the engines of creation, balancing the destructive hunger of black holes and keeping the cycle of matter flowing through the veins of the universe. How advanced can life get? The Kardashev scale measures civilizations by their energy use. We are Type 0, still burning dead plants, fossil fuels. A Type 1 civilization harnesses all the energy of its planet, controlling weather and earthquakes. A Type 2 captures the full energy of its star, perhaps with a Dyson sphere. A Type 3 civilization controls its entire galaxy, tapping into the energy of billions of stars and supermassive black holes. Looking at the stars, we search for signs of Type 3 civilizations, galaxies that give off too much heat or look artificial. We haven't found them yet. Maybe the engineering challenges are too great, or maybe they have evolved into beings of pure energy, needing no physical stars. Scaling this ladder is our destiny if we survive. It is a roadmap from the cave fire to the godlike mastery of the cosmos, turning us from observers into architects of reality. Let's confront a disturbing thought. The Boltzmann brain. Given infinite time and random quantum fluctuations, it is statistically more likely for a single brain to spontaneously form in the void, complete with false memories, than for an entire universe to evolve. This paradox suggests that you might not be a person living a life, but a solitary brain hallucinating this entire experience right now. The stars, the history, and this video could all be a fleeting dream in the dark. It challenges our concept of reality and probability. If the universe lasts forever, these freak occurrences become inevitable. Are you a real biological entity with a past? Or did you just pop into existence a second ago with memories implanted by chance? While physicists argue this is unlikely, the math of entropy makes it a haunting possibility. It reminds us that in an infinite cosmos, the line between reality and a trick of the quantum mind is terrifyingly thin. We believe diamonds are forever, but even atoms might die. This is the theory of proton decay. If protons are unstable and eventually break down, then all matter in the universe is temporary. Every star, every planet, and every person will slowly dissolve into a fine mist of subatomic particles and radiation. This process takes longer than the current age of the universe, but it marks the ultimate expiration date for the physical world as we know it. If protons decay, the universe will eventually become a sea of light without any solid objects. It is the final victory of entropy. Nothing built of matter can survive eternity. This thought is not meant to be sad, but to make us appreciate the now. We are living in the stelliferous era, the brief golden age where matter can hold its shape and life can exist. We are the lucky witnesses to the only time in history when the universe is solid and alive. Stephen Hawking posed a riddle that breaks physics, the black hole information paradox. Quantum mechanics says information is never lost, but general relativity says black holes destroy everything. When a black hole evaporates, does the information of what fell in disappear forever? If you threw a book into a black hole and the hole disappeared, where did the story go? If the information is truly deleted, then our understanding of the past and future collapses. Recent theories suggest the information might be stored on the surface of the black hole like a hologram. This leads to the holographic principle, the idea that our entire 3D universe might be a projection of information stored on a distant 2D surface. We might be characters on a cosmic screen. This debate is the front line of modern physics, trying to reconcile gravity with the quantum world. The answer could unlock the true source code of reality. In the incredibly distant future, if protons do not decay, stars will fuse into cold lumps of iron. These are the iron stars. Fusion stops at iron, so these objects generate no energy. They will just drift in the endless dark, the cold corpses of what used to be suns. At this point, the universe is a graveyard of metal spheres, separated by distances so vast that light can never cross between them. It is a universe of total silence and cold metal. Occasionally, two iron stars might collide, creating a brief flash of heat in the eternal night. But mostly, it is a dormant existence. This era lies roughly 10 to the power of 1500 years in the future, a number so big we cannot comprehend it. It shows that the bright, energetic universe we see tonight is just a spark, a momentary flash in a timeline dominated by cold iron and darkness. We are living in the universe's brief moment of fireworks. Drifting now in interstellar space are two tiny machines, Voyager 1 and 2. Launched in 1977, they are humanity's farthest ambassadors. They carry a golden record, a phonograph with sounds of Earth, greetings in 55 languages, and music. Long after Earth is swallowed by the sun, these small metal crafts will still be floating among the stars, carrying the memory of our existence. They are bottles thrown into the cosmic ocean, hoping someone, someday, will find them. The probability of them being found is almost zero, yet the gesture defines us. We have an innate need to be remembered, to say we were here. Even if no alien eyes ever see the golden record, it serves as a monument to human curiosity. We are the species that looked up, wondered, and built wings to touch the void. In a universe of chaos, the Voyager probes are a symbol of our order, our hope, and our desire to connect with the unknown. What is the universe truly made of? String theory suggests that if we zoom in far beyond atoms and quarks, we would find tiny, vibrating filaments of energy called strings. Just as the vibration of a violin string creates a musical note, the vibration of these strings creates the particles of nature. An electron is just a string vibrating in one way. A photon is a string vibrating in another. The universe is literally a cosmic symphony of music. This theory requires something strange, extra dimensions. Beyond the 3 dimensions we see, up, down, left, right, forward, back, there might be 6 or 7 more, curled up so tightly we cannot perceive them. We are like tightrope walkers seeing a line, while ants can crawl around the rope's circumference. If proven true, string theory would be the theory of everything, uniting all forces into a single elegant mathematical harmony that describes the song of creation. The most complex object in the known universe is not a star or a galaxy, but the human brain. We are the way the cosmos knows itself. Hydrogen atoms, given 13.8 billion years, have evolved into astronomers who study hydrogen atoms. This loop of consciousness is profound. We are not separate from the universe. We are part of it. We are stardust that has woken up, stood up, and started asking questions about where it came from. Without consciousness to observe it, does the universe really exist? Or is it just a quantum potential waiting to be collapsed? Our eyes give the universe meaning. Every time you look at the night sky, a photon that traveled for millions of years ends its journey on your retina. You are the destination of that light. We are the witnesses of the grand spectacle, the storytellers who give a voice to the silent, magnificent dark. Sir Roger Penrose proposes a poetic end, cyclic cosmology. As the universe expands and black holes evaporate, we lose all scale. A universe of only photons has no clocks and no rulers. In this state, the infinitely large, cold future becomes mathematically identical to the infinitely small, hot Big Bang. The end becomes the beginning. The death of our universe triggers the birth of the next eon, a new Big Bang emerging from the ashes of the old. This implies we are just one chapter in an infinite book. Before our Big Bang, there was another universe, and after ours fades, there will be another. We might be detecting signals from that previous universe in the cosmic microwave background. It is a comforting thought. Nothing is ever truly lost. The dance of existence is eternal, a perpetual motion machine of creation and destruction that plays out across time without end. We have traveled from the edge of time to the depths of the void. We have seen the birth of stars and colorful nebulae and the violent death of galaxies. We have peered into the quantum realm where reality blurs and looked out to the cosmic web that binds us all. From the mysteries of dark matter to the paradox of our own consciousness, the universe has shown us that it is stranger and more beautiful than we could ever imagine. This journey reveals one truth: exploration never ends. Every answer we find spawns 10 new questions. The horizon always moves back as we approach it, but that is the joy of science. The universe is an endless puzzle, inviting us to play. Whether we are alone or part of a crowded cosmos, the privilege of existing, of thinking, and of wondering is the greatest gift of all. We are the curious children of the stars. Thank you for joining me on this incredible 60-minute journey through the depths of the universe and the edge of time. It has been an honor to explore the cosmos with you. If this story sparked your curiosity, please light a beacon for us by hitting the like button and subscribing to Nightlight Science Stories. Your support helps us continue this voyage into the unknown, bringing the mysteries of the deep sky directly to your screen. Remember to look up tonight. The stars you see are your heritage and your future. There are infinite stories waiting in the dark, and together we will uncover them one by one. Until our next adventure, keep wondering, keep dreaming, and let the light of science guide your way through the night. This is Nightlight Science Stories, signing off. Stay curious, my friends.